So in the CNC basic, as far as the spool motion is concerned, three types of interpolation is implemented. One is point to point, which is required for drilling type of activity, which I have given that particular example of the speed ball. So in that case, the movement takes place in the space. So this bar is not important, only the correct location of the drill center position, that is important. So that is why it is called point to point. So once it reaches the correct drill center position, then the drill bit with the rotation along with the given feet, it is given a downward motion, so that up to the requisite depth it can penetrate, and after completion it will go up and move to the next location if more number of holes will be carried out. So that is what is the point to point. But as far as continuous operation is concerned, what we have already carried out in your CNC router, then the entire motions can be broadly categorized under the straight line interpolation and circular interpolation. What is interpolation? Interpolation, you know that is a very common mathematical term, implying that given the two extreme points, the function of the interpolation is to calculate or to identify or to determine the intermediate, closely spaced intermediate points, so that the locus of those points will generate the complete path in this particular case. In our steam table also we interpolate. So some steam related properties are available at 1 bar, 2 bar, 3 bar. Then if you are interested to calculate the steam property at 1.7 bar, it is not available. Then we take the 1 bar data, 2 bar data, then we interpolate. The same thing, two extreme points will be given. If it is a straight line, the tool is supposed to move from this point to this point. So our role is to specify the coordinate of this starting point and coordinate of the end point. So how system will understand whether I am interested to move the tool along this particular path. It may follow this path also, it may follow this path also. But this is our desired trajectory. So this interpolation function or algorithm will identify the what should be the different intermediate closely spaced points, so that the tool can be exactly navigated or guided along this particular path. So that is what exactly is the interpolation. So simple mathematical formulas are there, but it is also not very difficult to derive. So that will help to develop the interpolation algorithm, so that tool can be guided from point B1 to point B2. In our mechanical component manufacturing related to the NCCNC machine tool, it has got certain technical terms like taper, we call it taper turning, face milling. Okay, but fundamentally, as far as basic coordinate geometry movement is concerned, it is fundamentally a straight line. Okay, so for that purpose, one relationship can be developed. So just show you a glimpse of that. It is something like that. It will work dynamically. Starting point is value. This is the incremental value between this x2 minus x1, and n is the number of steps. Actually, how the tool will move? If this is my desired trajectory, that tool will follow this type of motion. This should be very close.
Step size should be small.
Should be small. Actually, truly speaking, the exact path cannot be generated, because there is no such guide system. Today, this inclination may be 30 degrees horizontal, another may have 45 degrees, another may have 75 degrees, but there is no such guide system that can exactly guide the tool along that particular desired trajectory. Only we have along x and along y, two orthogonal systems. So eventually it will be basically resultant motion. That is why this staircase effect will be there. Now these staircases are so small and so close that these error accumulated is accepted for mechanical purpose. Very small, 0.01 or something like that. So for x, that is why the two different relationship is there. One for x-axis direct system or control system, another for y-axis. And this will be the corresponding pulse frequency. So that is regarding straight line interpolation And another similar type of formula that is used for circular interpolation. If you want to generate a for something like that, it may be quarter circle, it may be half circle, any portion, but it's a part of circle. Knowing its start point, end point, and center point, and the radius. Then, as a part of the programming, we will specify the start point coordinate, end point coordinate, and the radius of curvature. But the system will be able to calculate approximately the intermediate points. So the determination of the intermediate points is basically the role of interpolation in NCCNC. So this is some sort of augmented version of the basic CNC, which falls under the category of lathe type of work, where actually job will be cylindrical. So for cylindrical type of job, rotation is important in the job, and tool have linear or motion. Tool will not rotate. So that category of machine is called turning center. And another, what is you have seen in your idea lab, those falls under the machining center. Their job is basically your prismatic type, rectangular shape, box, and the cutting tool rotates as well as up and down movement is also important in the job. So a lot of features are there, that is not such an element. So now this part I will discuss in a nutshell. So as far as this real activity part is concerned, what exactly we are supposed to do? So far what we have discussed, this interpolation, this control loop system, pulse count, these are for fundamentals and for your understanding knowledge purpose. But as far as the work part is concerned, given the job, given the raw material, knowing the cutting tool, what is available at your disposal, we have to prepare the entire tool path and other auxiliary function. So the entire information is a form of part program which the machine will be able to interpret, and accordingly commands can be generated so that cutting action takes place in an unmanned environment. The complete program is basically divided into block by block information. Just the base analogy will be understand that you have written one page of say essay or something like that. So fundamentally it is divided into single sentences. So one write-up composed of several sentences. Here also entire part program composed of several blocks. One complete sentence, whether it is very small or complex or compound sentence, it is meaningful to all of us. Here also, the block may be a longer one or may be a very small one, but it is meaningful to the machine control level, which it can interpret and execute the command. Again, coming back to our English sentence, it composed of some word, noun to noun, verb, adjective, adverb, place, computer. Here also, each block is composed of several words, and each word has got two parts. First part is alphabet, followed by some numeral. So entire block of information is available of the part program. So the word has got starts with an alphabet followed by some numerical, and this entire codes are developed according to the EIA standard RS 274. These are the commonly used address code which appears or which we encounter. A is sequence number, G is a preparatory function. This G code is very prominent and covers the wide range of activities. All the different functions are implemented through G codes. Technical name is preparatory function, but due to its character, popularly it is identified as G codes. So, whether it is point-to-point interpolation, linear interpolation, circular, because circular there will be two categories, clockwise, anti-clockwise. So, all these four basic motion, four G codes are there: G00, G01, G02, G00. Something like this. XYZ, which is basically for identification of the coordinate axis, and IJK are basically the radius vector. Okay, if you draw a arc, So this is the start point, this is the end point. Center point is somewhere here. This is the center point. Obviously, this is the radius. Now, if this arc is divided into two components, equal component, this will be the two components or the two perpendicular axis. Okay, so this intercept along x, y, z are identified by the address code IZ. So this is basically radius vector for circular interval. If it is in the xy plane, then xy will come. So in that case, we have to put the IJ value depending on your nature, and of course with sign plus or minus. And if z axis comes, it may also happen. It is not permissible with this machine, but in some machine, machining operation can be carried out in the xz plane or in yz plane. Then combinations will be jk or ik. Okay, that's the case. For feet, the address code is f. For speed, address code is s. For tool, it is t. For miscellaneous function, it is. So these are the address code that we encounter in case of part programming. And one block of information looks like this: N10, G01, X65, Z minus 23.5, S650, F1. This means the line number, simply the block will appear line by line. Okay, so in kth number, this particular commands are here. That is represented by N10. So sequence number, of course, also is optional. It is, we can omit it also. But sometimes we incorporate to identify a critical program line where there may be a possibility of error. So for quick identification, we can insert or incorporate the sequence number. G01, this interprets this motion, that means moving to point having coordinate 65 z minus 23.5 will be accomplished following state diagram. So G01 is the preliminary or G code for imparting state diagram. XZ coordinate value S650 is the spindle rotation RPM value is 650. F.3 it is 0.3 millimeter per evolution is the advanced. Okay, so it will appear something like this. The same thing of basically illustrated. I'll just show you some of the samples. So G002, G03, these four are basically motion commands. G04 is completely different. It's called dual. During motion, tool will not stop at any point of time. So long the program codes are there, it will keep on navigating through the space. But it may sure happen that if we wish to stop spindle, or if we want to give a halt to the cutting tool at some location for a few seconds, in that case G04 command is required. Now why it is required? From mechanical perspective, suppose I want to cut all of these four sides, so that this is a cutting tool, it keeps on rotating like this way, it is moving like this way. Now quite often it happens in the corner, some small chips or bars adhere even after movement. So in that case, what is recommended that having rotational motion, don't give any further linear or your speed movement. So hold that particular position for few seconds. In that case, there will be lagging, so bars will be eliminated. So if that is the intention, in that case you can use G0. Otherwise, it is not required. I told you that there are two modes of programming. How the system will understand whether those x45 z minus 26.5 is expressed in millimeter, in absolute or incremental mode. So at the beginning, you have to incorporate either G90 for absolute or G91 for incremental. Similarly, in a program, there is no reflection whether 65 is millimeter or centimeter or in inch. So at the beginning, you have to select mode G21. So whenever you specify G21, so all your XYZ values will be considered as it is expressed in millimeter. If you go for G20, then it will be expressed in inch. Now I have given two slabs. Some these ports sometimes vary from one machine manufacturer to other machine manufacturer. In some older machines, this G21 corresponding metric unit is taken care of by the G70. Anyway, you need not to memorize all these things. Just to have a look that this sort of G codes usually appear and we encounter frequently and effectively improper. Some other features G40, G41, G40. This is relevant to CNC milling. Maybe from the router. Whenever the tool moves like this way, all the four sides to be made. In that case, depending on the direction of movement of the cutter, there is G41 or there will be G42. From your side, you see the cutter falls on the left hand side of the finished part. From your side. So always it will be like this. Or you can move like this and always this way. So whether it is this way or this way, accordingly G41 and G42. Now, in the bracket I have mentioned, acronym CRC. What is cutter radius compression? Now, suppose this particular job will be carried out in large number, maybe 10. Suppose one cutter can take care of 5 or 6 jobs, after which it needs to be replaced. Suppose I carry out 2 jobs. Now, it may so happen that there will be accidental damage, or in the course of time there will be wear. Now, by replacing this cutter by another cutter, it may so happen the same cutter is not available. The cutter which is available, that is of different dimension. Diameter of this one and diameter of this is not same. So, whenever you take on this sort of jobs, it is expected, suppose if the job is rectangular like this, it is expected that cutter should occupy a position something like this. This is the top view. It will move. Again, after covering, it will come to this location. Anyway, it will move like this. Likewise, it will become moving. So it is so placed. Cutter center is so placed that this surface, that is the finished surface, should always make tangent to the cutter. Okay. Now, whenever the large diameter cutter or any diameter, suppose this is the initial diameter cutter, maybe 40 millimeter. And what is available right now, 40 millimeter is not available. Either 60 or say 20. I can use any one. So if I use 60, the location will be somehow like this. It is bigger than that, obvious center point shifts. And if I use 20 mm cutter, it will be occupying a position something like this. So whenever cutter diameter changes, your center point also shifted. But it is desirable that so long the job geometry remains same, I will not change the program. Otherwise, you have to duplicate your effort. That is not desirable. So this part is automatically taken care of by the system. That facility is known as cutter radius compensation. So only thing I use or the programmer or the operator is required, there is a page where against the tool number, diameter value you have to specify. Put just 40 or 60 or 20. So the system will automatically adjust how to position so that always the surface will be as a tangent to the cutter. And depending on the hand movements, it is either left or right. This is also another feature, as such not that much pertaining to the milling machine, but related to the turning center or lathe category of the. And these are some of the we call dedicated cycle or canned cycle. If you write manual program repeatedly, then it is very boring. Number of lines or blocks will be enormously high, and it will take a lot of memory space. So in that case, there are a lot of some dedicated cycle, which is popularly known as canned cycle or stop and hall cycle, which are developed separately, dedicated for specific type of operation. So they usually what we can do, some specific attributes we need to specify different parameters, and these are daily operation. So this you can see that this pole, all the 4 poles have same diameter, and of course their depth is also assumed to be same. So in that case, whatever attributes pertaining to one goal will specify in one at one location. And so after penetrating one goal, it will simply shift to the next one location and repeat the program. So that will be repeated for 4 different locations. So this sort of job is very common in mechanical fraternity or manufacturing. In this case, we use fake drilling cycle. Likewise, if there is some cylindrical part, if some groups are there, it is cylindrical job. It may so happen that there are certain groups are there. Some shoulder part is there. Necking is there. That is over this length, there is the diameter is lesser to fit something. So this is what this operation is called grooving. So in that case, we use not use that. Anyway, that is not incorporated. It is a different one, pattern repeating cycle. If any particular pattern is repeated continuously, then you can make use of this dedicated cycle G70. And this is, although I have forgot to mention, it is called G74 or 75. It will be called pegged grooving cycle. Pegging means some penetration, some withdrawal. Not continuously, it will move to the entire distance to give more life to the cutting wheel. Otherwise, there will be very high heat generation and continuous force exertion to give certain relief and for better evacuation of the chips. It is given a pegged movement that is possible or developed in case of drilling as well as for the grooving. Multiple thread padding cycle is very popular, required, frequently encountered in mechanical domain. If you want to make threads which appears in the board, so if we want to carry out your threading operation in a usual machine in the workshop, it may take more than 45 minutes, and continuous there has to be engagement of the operator. But using G76 cycle, the same job can be carried out within not more than 3 to 4 minutes. So this sort of lot of features are there. Those are called dedicated cycle. Particularly related to drilling, there are several cycles under the code G81 to 89. Actually, in the drilling fraternity, lot of small varieties are there. Some is called basically drilling, some is called boring, some called tapping, some called counter boring, counter sinking, chippering. Anyway, these are not relevant. So to take care of different geometrical activities, wide number of 81 to 89 lot of cycles are there. And if you want to get out of this after use, you have to give G80, that is scan cycle cancels. And the last one is G20, that is a home position. Machine has got a home position. Home name is similar to our societal aspect. Whatever what we undertake in a day, we start our journey from our home. Then you come to college, then you go to our shop, then you go to the library, go for dinner, go for market, and again eventually at the end of the day you return back to home. So for machine also, the tool has got a home position. So whenever you want to start the machine will start its movement from the home position. And after carrying out all work, it will have to again return back to the home position. So unless this home position is usually fixed by the machine manufacturer, it cannot change. So that is sometimes also referred to as machine geo. Okay, so that is fixed by the machine manufacturer. And in some cases, particularly for the longer machines, home position will be a different one, where tool change takes place. If you want to change the tool, that tool change position is also known as home position. Suppose a machine is very smaller one, so the tool traverse may be not this much. Okay, so in that case, job will be planned somewhere here. Now, in case of turning center or high productive machine, in one tool turret, lot of cutting tools are mounted. Suppose at any point of time, this finger as if a cutting tool, this is engaged for cutting. Now, after carrying out some operation, you want to index the tool such a way so that this third finger will take part in cutting. Now, for which I need to rotate my hand so that instead of this first finger, this third finger comes to cutting position. So this is what exactly is called indexing. To bring the exact tool to the occupied cutting position. Now, if there is not sufficient space, it may so happen, and all tools are not of same length and same geometry. So, while one tool is take part in cutting, other tool may collide with the job or some other machine member. That is why to facilitate this tool change, there should be sufficient free space. So, when the machine is longer, the chart in this side and the bed is so long, 2 meter, 2.5 meter machine is common. So, your machine zero is somewhere here. So, in that case, in between these two extremes, you can safely identify a space where this tool change will take place. So, that position is also known as home position. To restore the home position, a special code is assigned, that is G28. So, this is just finally. The coordinate is already I have illustrated. M04 and for spindle rotation clockwise or anti-clockwise, there are two codes M03 or M04. For clockwise M03 plus anti-clockwise M04. So if you specify M04 as 700, that means spindle rotation 700 RPM at constant anti-clockwise rotation. And this is another typical address code G96 S130. In that case, constant surface speed is important. Mind that at the very beginning I told you that one is RPM, another is this tangential velocity, which is pi dn by 1000. So this implies G96 S130. See, here nothing is written whether it is meter per minute or RPM. From this assigned G codes and M codes, system will be able to distinguish that G96 means this S is not RPM, meter per minute. That is assignment. So this sort of feature are there. As regard to the feet, it may be expressed in millimeter per minute or it may be expressed in millimeter per minute. Similarly, for tool change, M06 is the tool change command. This T03 is the tool number. Okay. Well, so you cannot identify, the system will not be able to identify what is the purpose of different fingers. But you can simply identify 1, 2, 3, 4, 5. So if you are interested to bring this third tool, so you have to specify each tool. That is the indication. Some other machine functions are spindle on off, tool change, student on off, and program stop. So this sort of some sort of popular M codes are there. So these are the steps of programming. Just one slide I will have a so you will give at the beginning I was talking about the capital integration of the advantage. That is the flow chart of the how the capital integration system makes it possible to reduce our total. In the CAD platform, we can found in the CAD system, first we generate 3D geometry. There is a drawing. So from the drawing, whenever you get the drawing, the geometry database is stored in the machine. So same geometrical database is utilized for programming part. So you need not to put some extra effort once again to identify the corner points. So from the geometry through your mouse interactive mode, you select the tool motion. You define the tool is supposed to go along these 4 corners. So we just through the mouse you pick up these points and it will show by highlighting. And then sequence of operation. As I told, whether you would like to move like this way or that way. That is your sequence of operation. Or it may so happen that in addition to this all 4 sides meaning, there may be the last operation, but there you can have some wedge cut like this. So according to your choice, according to of course logical manner, you have to identify the sequence of operations and part of the machining parameter. That is the same level of speed, feed, and depth of part. Then when everything is you have defined, the system will automatically process the data and through post processing it will generate the basic program. So what G code M code we have seen, which in manual mode we are supposed to write individually, that part is not required. Machine depending on your guidance from the geometry database and some level of speed variable and your path, system will automatically generate the program. And that is what exactly is done with existing machines. And finally, so the post-processing or post-processing means basically generation of G codes and codes. Your CNC machine is. So that's all in a nutshell. If you have any general queries, just you can address.
Code input that should be containing some kind of algorithm.
G code input?
Which is inside the G code. Some kind of algorithm should be there.
It is already inbuilt. The system will interpret the G01 means it will initiate this particular function. If you want to move for circular clockwise, you have to assign G02. So automatically it will move along this path. If your objective is to go to point to point, then corresponding G code will be G02. So each one movement has got some unique address code. This means this means this. So those codes we have to remember slowly and you can easily what people do, even mechanical people do, some code automatically remember and some specific particular things are supposed to appear in specific CAN cycle. Okay, lot of in between if you explore, a lot of address parameters will be coming. We call it as an R parameter, P parameter. That they are not possible to. And again, in some system, particularly Fanuc is a very popular controller. Fanuc controller. Machines are run on different controllers. Some are Sinuali is a Siemens controller. Fanuc is a Japanese controller. Sinuali is a German controller. So this may vanish. Again, during specification of the some dimension, some needs to be specified in micron, some in millimeter. Okay. But you need to write, there is no condition to write million or mm, it is not there. If you wish that your data plunge depth in doing should be 5 millimeter, your corresponding Q parameter will be 5000. Again, it is the same block, again some other parameter, again you have to put 0.1. So 0.1 is in millimeter. Very good. So you need to, for anyone, you need to consult the catalog, programming catalog provided by the machine. So this is in a brief. Any other question? Generally,